Good afternoon, my name is Evan Budd. I'm in section 4 for my Chemistry 110N lab. This is my oral report for experiment number 2, which is reactions of copper and yield percent. So, at the beginning of the experiment, it started off with just copper, right there. Throughout the experiment, nitric acid and sodium hydroxide was added to the copper. It was then heated. After it was heated, sulfuric acid and granular zinc metal was then also added to the solution. During the experiment, the reactions were written down on page 12 in detailed observation sheets stating the color changes, changes in physical state, and evolution of heat in the lab manual. So first, after the reactions occurred, they were then transferred to page 10 of the lab manual into figure 1, copper reaction scheme, which is this. First, nitric acid was added, HNO3, which is nitric acid, was added. Excuse me. The reaction of this was a brownish red gas, which, if we look over here, on here, it was a brownish red gas, which was NO2. So in this box right here, it would be NO2, and that's a gas. And this box, as it says here, the bowl box should contain a copper compound. So this box has to contain a copper compound, which then caused, so adding the nitric acid, was a brownish red gas, which then caused the water to turn bright blue. So that's the water right there. Turn bright blue. And then what we got was, for the copper, it would be CuNO3 because it's a bright blue water-soluble salt. So, which is an aqueous. So right here we would put CuNO3 2. Okay. And then for the and then this was aqueous. I forgot to write that. I'm sorry. Aqueous. Okay. And then sodium hydroxide was added, causing the bright blue mixture to turn into a royal blue substance. Now, if you look on here, there would be CuOH2 because it's royal blue, and that's the only royal blue on the sheet that we are given. So the copper compound right here that would go is CuOH2. So right here is CuOH. Okay. In CuOH2, it's a water-soluble salt, as said here. Water-insoluble salt, my bad. And that soluble salt would be NaNO3 because it's white salt dissolves in water to yield a colorless solution. So right in this box we would write NaNO3, which is an aqueous solution. So NaNO3, an aqueous. And then I forgot to put this as a solid right there. Okay, so we got these two filled out. Since we added the sodium hydroxide and the nitric acid to the copper, we then heated it. The solution was then heated, and during the heating process, the solution turned into a blackish color with all the salt sinking to the bottom. So if we look back onto here, it says black water insoluble salt. So that has to be the answer for that one. So this box would be CuO, and that's a solid. And then the salt was being separated from H2O. So this one would be H2O, and that's a liquid. Okay. So after that, sulfuric acid, H2SO4, was then added, causing a reaction, turning the solution into a bright blue solution, which is now CuSO4 in aqueous. It's CuSO4 because it's bright blue water-soluble salt. So this box right here would be CuSO4, and that's aqueous. Oh crap, I don't know how to say it. Okay, and then, which is now CuS4, which we did, with water still being present. So this would still be H2O liquid. Okay, so now that we have that, we have to add the zinc into it. The zinc added to the solution, causing the zinc to bubble when we added it, releasing a colorless gas. And right, if we look on page 8 of the lab manual, table 2.1, we would see that right here is a colorless gas. That would be H2. H2 would then go into this box right here. So H2 gas. Boom. Okay, zinc was also added into here. So with zinc in there, we look on the table to see if there's any zinc. And obviously zinc was added in, so zinc has to be 1. So right here we would put Zn2+, which is solid. Okay, then the other one would be ZnSO4, which is right here. White salt dissolves in water to yield a colorless solution, which is true because once the zinc was added, the solution turned back into clear. So right here would be ZnSO4, and that is aqueous. Okay. So now that we did the table, we have to find the percent yield. So the percent yield is the recovered mass of copper divided by the initial mass of copper. So to find that, we go over here and we have to find the mass of copper recovered, we must subtract the mass of evaporating dish and recovered copper by the initial mass. So the mass, the mass of the evaporating dish and recovered copper is 41.117 grams. So right here we would, oh my calculator, jeez, I'm so stupid. So right here we would have 41.117 minus 40.562. That gives us 0.55. Now the initial, to find the yield, like I said earlier, we have to do the recovered mass of copper, which is this, divided by the initial mass of copper multiplied by 100. So the initial mass, the recovered mass, is 0.555 divided by the initial mass of copper, which is 0.503, multiplied by 100, and you get the percent yield of 110. So with this, there's experimental errors. Experimental errors could either be greater than 100% or lower than 100%. In our case, the experimental error, the percent yield, was higher than 100%, with it resulting being 110.338%. Now, some of the experimental errors that we have had happen was that there was copper still left on the capillary tube, and while decanting, some of the copper came out, which altered the initial the recovered mass. We also added too much zinc when we had to add zinc, so we had to keep decanting to get rid of all the zinc. And then